All right, so in chapter 2, we focused almost entirely on the nucleus. Okay, and if you will remember, the nucleus contains protons and neutrons. Now, for chapter 3, and really for the rest of the class going forward, we are going to focus almost entirely on electrons. All right, so chapter 3 is on electrons. Now, why do we care about electrons? Electrons are essentially what give us bonding. They also dictate actually quite a few of the chemical properties that a given element has, but we're going to focus on them in chapter 3 specifically because of bonding. All right, now, if you will remember, let's go back to our friend carbon. All right. I'm just going to illustrate the nucleus as a sphere now. And if you will remember, we said that carbon has 6 electrons, right? 6 protons, it has 6 electrons in its neutral state. We're going to talk about non-neutral states in chapter 3 also. But previously, the way we illustrated them was something like this. Okay, something like that. Turns out that's actually not particularly accurate. So electrons exist in these things called energy levels. And really, we're not even going to use that term in here. Instead, what we're going to refer to are electron shells. Now, the model that we are going of the atom that we are going to use in here is what's called the Bohr model of the atom. It's a fairly old model, and we do have better, more current models now. In particular, where we talk about orbital shape and things like that, but those really are beyond what we need to know in this class. And so we're going to stop at using the Bohr model, and that will cover us for everything. Now, there again, in the Bohr model, we have these things called electron shells, where electrons live, so to speak. All right, so let's look at our carbon atom here again, and let's put an electron shell here. All right, we're going to call this the n equals 1 shell. I'm going to just go ahead and start making a chart here. Right. Turns out the n equals 1 shell can actually just hold 2 electrons. Right? So if we look at our carbon, we have 2 electrons in the n equals 1 shell. Yeah, we have 6 total, we know. So they have to go somewhere else. And where we're going to put them is, or where we're going to start putting them now is in the n equals 2 shell. Okay? The n equals 2 shell, of course, is larger. And it turns out the n equals 2 shell can hold 8 electrons, right? But we've accounted for 2 of them so far. So really, we just need to put 4 electrons in the n equals 2 shell, right? Even though it can hold a maximum of 8. Now, we go on out from there. Of course, our next shell is called the n equals 3 shell. That holds 8. Very rarely will we go beyond the n equals 3 shell. But if we go to n equals 4, we can actually put 18 electrons in it. All right. You'll notice, let me make a point of this, okay? Most of the elements that we deal with, we're going to be looking at the n equals 2 or n equals 3 electron shell. Notice that they can hold 8 electrons. Okay. We want full electron shells, right? Compounds want to fill their outermost shell of electrons. By the way, let me backtrack a little bit. In a ground state atom, don't really focus on that term. Just know that everything that we do in here, we're going to assume that we're in the ground state. In a ground state atom, we fill the lowest energy levels first before we move on and start filling a higher energy level. Right? So that's how we arrive at this. Now, our outermost shell of electrons we call the valence electron, the valence shell. And of course, the electrons that are in the valence shell we call the valence electrons. Now, for most of what we're going to deal with in here, we really like to have a full valence shell. And there again, if most everything we have, we're going to be dealing with the n equals 2 or n equals 3 energy level, that's going to mean 8 electrons. So when we form compounds, we actually look for ways to get 8 electrons in the valence shell, and that is called the octet rule. And if there are 8 electrons present in the valence shell, then that means that we have fulfilled the octet rule. Now, for n equals 1, even though I don't really like the saying it this way, because octet means 8, we will sometimes say that if we have 2 electrons in the n equals 1 shell, and that is our valence shell, that we have a full octet, even though that's a little bit weird of a wording, at least to me. But anyway, that is what we have going on in here. And this is called the octet rule. And as I said, all right, let's do a little bit more complicated of one. Let's look at chlorine. Now, chlorine has 17 electrons. Right? So let's put our 2 in our n equals 1 shell. Then we can put we can put 8 in our n equals 2 shell. There's 8, but that still only gives us 10 electrons. So we have to go out to our n equals 3 shell. And we have, so there again, we have 17 electrons total. So we're going to put 7 in our n equals 3 shell. All right. Now, just to kind of plan an idea, this is a section 3.2 topic, but think about what we would need to do to get a full octet in our n equals 2, or what we would need to do to get a full octet in chlorine. All right, now let's go back to the periodic table. Now, if we look at our periodic table, it turns out that there are trends that we can use to predict the number of valence electrons that are going to be present. All right? So, if we look in group 1 always has 1 valence electron in its neutral state. Group 2, we have 2 valence electrons. Group 13, so we pass over the transition metals because we can't really predict those. But we will talk a little bit about how we deal with those. But anyway, there's no real trend to those that we can look at least at this level of class. We go over to group 13, which on older periodic tables is actually called 3A. But group 13, we're going to have 3 valence electrons. 14, we're going to have 4 valence electrons. 15, we're going to have 5 valence electrons. 16, we're going to have 6 valence electrons. 17, we're going to have 7. And of course, 18, we're going to have 8. Now, I believe I talked about this some in chapter 1 when we looked at the periodic table, but we call group 18 the noble gases. Noble gases already have a full octet. That makes them very non-reactive. But anyway, that is our trend for valence electrons and how we can look at the periodic table and predict the number of valence electrons present. All right, and that covers us for chapter 2, or I'm sorry, for section 3.1, not chapter 2.